So this is going to be a little bit of a review. This thing balances back out. But this is going to be a little bit of a review on all of this matrix stuff that we've been talking about. Some super basics, which I feel like most people are okay with, but just to make sure, I kind of talked about creating a study guide, right? So making notes to yourself, add matrix, right? All we do is make sure that the dimensions are the same. Okay, they have to be the exact same size. They don't have to be square, but they do have to have the same dimensions. So same rows, same columns, right? So same, right? Dimensions are the same, and then all you're doing there is just adding the element spots, right? So elements in their spots. When you're creating your own study guide, you want to put these things in your own words the best that you can so that you know what's happening, right? So adding elements in corresponding spots is what I would write. And then if you want to give yourself a little example, alright, if I want to add these two things, they have to be the exact same size. I'm just making up a random matrix there. But to add them, right, and then you're just adding corresponding spots. So like the first row, first column, you add those together. And then 1 and -1 makes 0. 3 plus 0 makes 3. I'm just adding the things by their spots. 1 plus 2 makes 3. 2 plus 4 makes 6. And 4 plus 1 makes 5. So that's how that goes. And then if you want to make yourself a note there, subtraction is the same. Right? So subtraction is the same thing, only you subtract instead of add the numbers. So you would subtract everything in that second matrix there. Adding and subtracting seemed like everybody had that on the quiz for the most part. But the dimensions do have to be the same. Super important there. And then we had multiplication by a scalar. Okay, those are called a scalar, that number out front. If you need to make yourself a note, right, write number out front. And that you just multiply every element inside. Alright, so multiply all the elements inside. So if I had something that looked like this, okay, then I'm just going to multiply each and every piece. So 2, 4, -2, 6. Super simple. That's multiplying by a scalar. Multiplying matrices together, a little bit different. We kind of talked about the fact that the columns of the first, this is multiplying matrices. Okay, so if I have two matrices that I'm trying to multiply together, sorry, getting a lot of control already. If I'm trying to multiply matrices together, columns of the first have to match the rows of the second. Alright, that has to be true. So columns of the first have to match up with the rows of the second one in order to do multiplication. And then you're going across the row on the first matrix. And then down columns on the second while you multiply. Okay? The idea over here on this left-hand side, and I'm not going to do this for the whole entire thing, this is just to kind of give you an idea of how I would go about studying for a test like this. So you need to know like what that means. So like if you see something and it's multiplying matrices, you just need to know mentally what to do. We're focusing too much on individual problems and not on the overall idea. But something like this, if I'm going to multiply, I know that's going to be multiplying the across on the first one and down on that second one. So in whatever way that you have to explain that to yourself so that you know that that's what you're supposed to be doing. So that's what you kind of need to look at. So let's just say I have something like a 2 by 3. Right, so then in order to multiply the next one, it has to be a 3 by whatever I want it to be, right? It can be a 3 by 1. I'll do that because it's fast. 4, 6. Alright, it can be a 3 by 1. I'm going across the rows and down the columns. So in order to do this, so this right here was a 2 rows, 3 columns. This is 3 rows, 1 column. So my result should be a 2 by 1. I know that's true because those outside numbers create your resulting matrix. So that kind of helps me. So it should have 2 rows and 1 column. So then when you go to multiply this out, so this is 1 times 2 plus 0 times 4, which is 0, plus negative 2 times 6. Okay, so that would give you your first number. And then you do that exact same thing for the next one. So this would be the first row, first column. And then you do the same thing here. 2 by negative 1, 2 by 4, and then 3 by 6. Alright, notice that I never leave one hand in the same spot. I always am moving. I'm always going from left to right and top to bottom. Okay? The idea here is that every row will get multiplied by every column. Okay? Because our answer is rows by column. So every row, okay, the 2 rows by every column. If this was a 3 by 3, I should be doing 2 rows by 3 separate columns. Okay? And then you add all that up and that gives you that resulting matrix, which should be a 2 by 1, and it is. So this is 2 plus 0 minus 12, which gives you negative 10. And then this one is negative 2, positive 8, which is 6, and then 18, which is 24. Okay? So negative 10, 24 would be the result there when I multiply that out. Alright, so that's multiplication of matrices. So those were the basic operations. And then we got into what we do with matrices, right? So the whole idea behind matrices is that we can use these to solve systems. We can do lots of things with them, but their main purpose is to use them to solve systems. One of the main concepts that we've been talking about through this whole thing is that if I have like matrix A times matrix B, and it equals matrix C, okay, so no matter what these matrices look like, assuming that you can actually do the multiplication here, whatever these matrices look like, if I want to solve, let's say, for B, so let's say that they give me some kind of values here for A and for C, and I wanted to solve for B, then I can find the inverse matrix here, okay, and we represent the inverse matrix by that A negative 1. Sometimes you see it inside, sometimes you see it outside. Really depends on who wrote the book on how they actually wrote it. Sometimes they don't put the matrix brackets at all. They just do the A, B, and C. But the point is that if I multiply, let me not put that there, but if I multiply that into both sides, and remember the order matters because A times B and B times A are not the same thing, so you do have to put it in the correct order. If I multiply it on the left on this side, I have to also multiply it on the left on the right side of the equation. So if I do something like this, times A times B equals, right, A inverse times the C. Okay, well, these two right here create the identity matrix, which the identity matrix is that thing that's got like the 1s across the diagonal and everything else is 0s. This is like the equivalent of 1 in the matrix world. So it's like multiplying by 1. So this essentially just goes away.
Frederick York. You need in the front rotunda area. Frederick York.
And
Front rotunda.
so then you're left with the matrix B, which is equal to whatever you get when you multiply these two matrices together. Okay? So this is the basic concept behind all of these things that we're doing. And now we've learned all of these other shortcuts that we can do and we can get to, but this is the overall concept. And we gave you multiple ways to get to the inverse. We've given you multiple ways that we've found what we call the determinant, and we'll kind of go through all that. But this is the overall concept of what we're trying to do. So one thing that they ask of us is to find a inverse, right? So we've got to be able to find an inverse, and they give us multiple methods. So let's say I want to find an inverse. Okay, so finding an inverse, there's multiple methods. Method 1, okay, you can just do the Gaussian elimination with the identity. Gaussian elimination with identity. Okay, so we're going to create those the augmented matrix, right? We talked about the augmented matrix, where you make the little line and you write two matrices really kind of combined into one. So you can do that. Okay, this works well with 3 by 3 with any square. Really, any square matrix. Okay, so you can do this with any square matrix. So you can do this with 2 by 2s. You can do this with 3 by 3s, 4 by 4s, any of that stuff. You just put. We're just going to pick a small one because I don't want to be here all evening. But you do -3, 2, -1, 4, right? And then, sorry, you shouldn't put a bracket there. You just put a line, and you create an augmented matrix. And on the right-hand side, you put that identity matrix. Okay, the identity matrices are always the same. They have ones going across the diagonal from top left to bottom right, and everything else in the matrix is a 0. They should be square, meaning the dimensions of the rows and the columns should be the same. So from here, you're trying to do Gaussian elimination to create the identity on the left-hand side. Now, to do that, it's going to look different in every single matrix. It just depends on what you're aiming for. The same goal happens, though. You want to start with trying to get the 0 in the bottom left. All right, so if you need to make yourself a note, 0, bottom left. Okay, no matter what size I'm looking at, I'm going to do that first. I'm going to start with the 0, bottom left. Okay, and then I'm going to create zeros in that whole first column. Right, so zeros in the first column, except for the one in the top left, right, because you need to have a 1 there. So I'm going to go zeros, if you need to put bottom of the first column. Okay, and then I move on and I'll do the zeros. If I have more than just a 2 by 2, then I'll do the zeros in the second column, right? So then second, third, etc. Okay, but all in the bottom there. So we start off in the bottom creating those zeros, and that way whenever I go to start working towards the top, I'm adding zeros up, so I'm not changing values I had already fixed. So like here, if I want to create a 0 here, well, this is -3, so what we're allowed to do is we're allowed to swap rows. We can multiply by scalars, and we can add and subtract rows. So I can multiply this whole thing by a -3, and that would give me a +3 and a -3, so that when I add those two rows together, I would get 0. So that's what I'm going to do. So I would say row 2 is the one I want to switch, so that's what I'm going to write first. And I want to multiply it by -3, and then I want to add to that row 1. Because once I multiply this by -3, it gives me +3, and when I add -3 to that, I get a 0. So that's what I'm going to do. So I'm changing row 2 here, so I'm going to leave row 1 perfectly the same. Not going to change it at all yet. We'll get there eventually. We'll have to, but for right now, I'm just going to do, and I'll do it off to the side here, so we're going to do -3 times row 2, which would give me a +3, a -12, 0, and -3. And then I'm going to take that and add to that row 1. So -3, 2, 1, 0, 0, -10, 1, -3. So then you put that down here as your new row 2. Okay? So then from there you have some options. You can either work on getting this into a 1, but the only way to do that is divide by 10, and then these become fractions. So I'm not going to do that just yet. I'm going to go ahead and get my 0 up top here. And that would be my next step. So here, in order to get a 0 here, this would need to be a +10, so that when I add, those give me 0. So in order to get a +10 here, I would need to multiply by 5. So I'm going to go 5, row 1, and I'm writing the row 1 first because that's what I'm going to change. And I'm going to add to that row 2. So that's going to give me, and I'm going to do the math right here for you. So then 5 row 1, so -15, +10, +5, and 0. And then add to that row 2, 0, -10, 1, and -3, which gives me -15, 0, 6, and -3. Okay, so -15, 0, 6, negative 3, and then 0, negative 10, 1, and negative 3. So the reason why I don't start with trying to get 1s here is because if I were to do that first and get 1s in here in these two spots, then when I try to get the 0s in the other spots, they tend to change, and then I have to go back and do them again. So that's why I start with the 0s. That way, when I add and I do stuff like that, it doesn't change it. So when you add 0s to things, they just stay the same. So now I need to get these to be 1s, and you can just do that by multiplying by that reciprocal. So I'm going to do that for both of them. So I'll do negative 1/15 R1. I will also do negative 1/10 R2. And do those both at the same time. So when you do 15 times negative 1/15, you end up with 1, 0, negative 6/15, and I will reduce those in a second, positive 3/15, and then 0, this would give me positive 1, this would give me negative 1/10, and this would give me positive 3/10. You do need to be comfortable with fractions. I would be very willing to bet they're going to show up on your college exam. I don't know. I haven't seen it, but I would be very willing to bet. So anyway, so all of that was to get this guy here to get my inverse. So this is an inverse. So the inverse of this whole thing is the matrix. And I'm going to go ahead and reduce this because 3 can come out of both of those. So that would give me negative 2/5. That would give me positive 1/5. That would give me negative 1/10 and positive 3/10. Okay, and that there would end up with my, that would be my inverse of that particular matrix that I started with. So now, if I was trying to solve something, if I had something to this particular case, and I had values, if this is the values for A, well now I have that A inverse to multiply into both sides. And so then I could finish solving for matrix B by multiplying my new inverse by whatever matrix C they had there. So that's how you find an inverse using the Gaussian elimination with the identity. Okay, there are faster ways. That's the longer way. The nice part about this is that this is the only way they actually gave us to do a 3x3 is with the identity over here. So this is the only way they gave us for the 3x3. So if you want to kind of make your note over here, all right, 3x3, this is the method that they gave us. They didn't give us anything for another method for the 3x3 or anything bigger. There are other methods, but this is the only one they gave us. So if you're trying to find the inverse, and they might ask you something like, it might just be as simple as find this, right? That means find the inverse of M, whatever the M matrix was. So then from there, we've got method 2. Okay, so method 2 of finding the inverse. I guess I could write that up there, right? Finding the inverse. Okay, so finding that inverse, or A negative 1 or M negative 1, it's the negative 1 that creates that inverse. So the second option here was using the determinant, and I'm going to do the exact same problem, just so we can kind of double check things, right? So using the determinant was the second option, right? So method 2 was using the determinant. Okay, the only one that they gave us for this using the determinant is for 2x2s. Okay, so we're going to use this with the 2x2s. It's definitely faster. This is the only thing they gave us. There are other ways to use the determinant for 3x3s and 4x4s and things of that nature, but the only one they gave us was for the 2x2s, and it looks like this: 1 over the determinant of the matrix is equal to dA negative B and negative C. Okay, so what this thing means here is that if you think about the fact that this is A, B, C, and D is the originals, okay, these two are going to flop. Okay, they switch spots, and then these ones just change signs. Okay, so whatever the original sign is, you're just going to switch those signs. But you also have to have the determinant. Okay, and the determinant you find by multiplying down and across, minus down and across. The formula they gave you is A times D minus b times c. Alright, down and to the right minus down and to the left. Okay, that's kind of how that goes. Down and to the right minus down to the left. A lot of you guys have been calling it cross-multiplying. It is definitely not cross-multiplying, because cross-multiplying implies there's an equal sign that we're going over, but if that's what you need to help you remember it, that's perfectly fine. Okay, so determinant, okay, we're going to use that to find the determinant, and then you just use this process. So I would do negative 3 times 4 minus 2 times negative 1. Be very careful with your signs. A lot of you guys are just messing up on signs, right? You just pay really close attention to all your sign work. Negative 12, positive 2 gives me negative 10 as my determinant. And then from there, I'm going to do 1 over the determinant, which is negative 10, times the matrix where I flip those around. So 4, negative 3, negative 2, positive 1. Okay, so I switch those, keep the same sign, 4, negative 3, and then these two just switch the signs, negative 2, positive 1. Okay, and then you multiply that out. Okay, and you get negative 4/10, you get positive 2/10, you get a negative 1/10, and you get a positive 3/10. Alright, and then when you simplify that down, our inverse here is negative 2/5, positive 1/5, negative 1/10, and positive 3/10. And hopefully, if we did our work right on the previous one, right, you get the exact same answer. Negative 2/5, positive 1/5, negative 1/10, positive 3/10. Sorry. Alright, so you end up with that exact same answer. Obviously a lot faster. Okay, so obviously a little bit faster. So this is a really nice shortcut if you are doing finding the inverse. But again, this is for finding an inverse. And then if we were trying to solve, we would have to take that inverse, multiply it by the matrix on the other side of the equation in order to figure out what that matrix over there is equal to. Okay? So that's what all of that is. And that covers determinant. So the determinant on the 3 by 3 we also did, but with the determinant on the 3 by 3, so we did figure out how to do the determinant on a 3 by 3, and you just multiply down and across, and I'll kind of show you that formula there. And you can look back, you should have this in your notes if you took notes, right? The way I do it is to write the 2 columns next to it, and then I just go down and across. Okay, so all of them, if this is a 3 by 3, they should have 3 numbers that we're multiplying in each one. So here I get the 2, so I don't have to do anything with that. So down and across. Okay, and when you go from top left to bottom right, those you add together. And then when you go from the top down to bottom left, so when you go the other direction with them, and I find those products, and those are all going to be minuses. Okay, so it's plus, 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 minus, minus, minus. If it was a 4 by 4, it would be the same thing, but there'd be four numbers in each one of them, and then there would be 4 different pluses and 4 different minuses. So that's kind of what that looks like as far as finding the determinant. So multiplying down and across, and then subtracting the down and across from the other side. But again, we didn't do determinants to solve or with a 3 by 3, so that's why we're kind of not spending a lot of time on that now. So we just talked about all of that. So you might get, this is what I was kind of talking about, so I might get something like this, and I'll just show you one here real quick. Okay, so here's going to be solving for the matrix. So I've got something that says 2, 1, 4, 3 times B, and it doesn't even say times, it just says B equals 1, 1, 2, and 4. I think this threw a lot of people off. They thought it was like matrix, this matrix, and then B equals, and they weren't real sure what they were doing. But this is like an equation. So just like we have 5x equals 1, we would multiply by the reciprocal, right? Okay, that's the inverse basically. This is multiplication, this is division, so it's that inverse operation is kind of what's happening there. So it's an inverse, so those cancel out. You get 1x, which is equal to 1/5. We're doing the same thing here, so I need an inverse of this thing in order to multiply to both sides. So I'm going to find the inverse. Okay, so if this is the original, so if a equals 2, 1, 4, and 3, right, then to find the inverse, it's going to be 1 over the determinant of a. I'm obviously going to use the shorter one because this is a 2 by 2. So 1 over the determinant of a, d, negative b, negative c, positive a. Okay, so we're going to make it fit this. So first find that determinant. So the determinant is equal to, down and to the right, 2 times 3 minus 1 times 4, which gives me 6 minus 4, which gives me 2. So the determinant there is 2. Keep in mind that 2 goes on the bottom, though, so a lot of people are missing that 1, right? It's 1 over the determinant. So then it would be 1/2 times the matrix. Swap those. Becomes 3, 2, and change those signs. -1, -4. Okay, multiply that out, and you get the matrix 3/2, -1/2, -2, and +1. Okay? So from there, sorry, got to get a new pencil. So from here, but this right here is the inverse. So this is your a, -1. So this is not an answer. This is the inverse matrix, which is what we talked about, but this is what we use to solve this equation. So I'm going to take this whole thing, 2, 1, 4, 3. I'm going to multiply this to the left, 3/2, -1/2. -2, 1. If I multiply these together, if I did my math correct, that should give me the identity matrix, which is basically like saying 1. Okay, so b equals, and I'm going to multiply it to both sides, just like you do an equation, -2, -1/2, +1. Okay, so that times what we had over here for c, which was 1, 2, 1, 4. Okay, so here, these all just go away because it makes the 1, right, the identity matrix, so it makes 1 essentially. So b is equal to, now I need to multiply this out. Okay, 3/2 minus 1/2. Okay, going across and down, right? And then the next one would be 6/2, which is 3, minus 4/2. But I'll do all the simplifying fractions. I'm kind of showing you how to simplify fractions while I go. All right, multiplying numerators together. There is no denominator, so it's just times 1, right? So -2, or -4/2 there. And then move on. So second row times first column, -2 times 1 is -2. And then 1 times 1. And then second row, second column, -4. And then 4 times 1 makes 4. All said and done, 3/2 minus 1/2 makes 2/2, which makes 1. Okay, that's 3 minus 2, which makes 1. -2 plus 1 makes -1. And -4 plus 4 makes 0. Okay, there it is. That would be your matrix B. So if you take and you multiplied this matrix by your B matrix that you just solved for, you should get this as a result. Okay? So that's what those things look like. That's how you go about solving when they look like that. Now they also gave us Cramer's rule. Okay, and there was a lot of stuff going on, but when it was all said and done, the way Cramer's rule works is that x is going to equal the determinant of x divided by the determinant, and then y is going to equal to the determinant of y over the determinant. Okay, and to get the determinant of x, you need to make a new matrix. Okay, and the new matrix, you replace the x column, right, new for dx. Alright, you're going to make a new matrix with the x column replaced with the equal. Okay, so that's what I would write for myself as a little note, right? So dx is going to be the new matrix. with the X column replaced with the equal. So what that means is that if I have this, so if I have -2, 1, and then 1 and 3, and that's equal, times xy, and that is equal to 5 and 7. So I'm taking this system, right, and then I'm pulling, for the first matrix, I'm pulling the coefficients of each one of these. Make sure that they're in order, x's, y's, and then numbers, and then I'm putting those coefficients there. And then times xy. Super important concept here. When you multiply this back out, you should get the original. -2x, +y, equals 5. Okay? Same thing here. +x, +3y, equals 7. So please make sure that you can do that. So if you go to multiply this matrix back out, right, you should end up with the same system that you started with. That's going to help you out later on. Okay? So then from there, if I have something that looks like this, the way that we could do this by finding the inverse matrix here and multiplying both sides by the inverse matrix. So this is another method for solving. Okay, this is another solving method. We just did one a second ago. Okay, so one of them is to find the inverse matrix, multiply it to both sides, and that gives you this right here. Okay, so this is another solving method, which is Cramer's rule. Okay, making notes to myself there. All right, so Cramer's rule. You're going to make that new matrix with the x column replaced. So what we do is, this is my x column, right? Because if I were to multiply, these are the ones that get multiplied by x. So I'm going to replace that x column with the equal column. So I would get 5, 7, and then the other one stays the same. So it stays 1, 3, okay, because that's what this one was. And then you just find the determinant there. So your determinant of x would be 15 minus 7, right? 5 times 3 minus 1 times 7. Okay, so that gives you the determinant of x. And then I need to do the same thing with y. Okay, so dy, same, but with y column. Alright, same thing, but with the y column for the dy. So I make my little matrix here. So the x column is going to be the same this time, -2, 1, and then instead of the y column, we put the equal there. And do the same thing. So dy is -14 minus 5. Make sure you guys are subtracting that second one. A lot of people have been adding, right? -14 minus 5, so we get -19. And then, final thing, to get my x value. So to solve for x, you take your dx over the original determinant, which I haven't found yet. So the original determinant is just the determinant of literally the original one. So it would be -6 minus 1, which is -7. Okay, so original determinant, so it's just a bunch of determinants. So that's all Cramer's rule is. So 8 over -7, and then y would equal to -19 over -7. Or just 19/7. Please make sure that if it's a double negative, you have to change that to positive, or the Canvas portion will count that wrong, even if you have everything correct. Okay, because they don't put negative over negative. So make sure you change those to positive if you have that double negative like that. But that's what Cramer's rule looks like. So Cramer's rule you can use to solve. Again, there's ways to use Cramer's rule with it. So Cramer's rule still works if it's a 3 by 3, but you would have to find the determinant of the 3 by 3, and then this gets a little bit more complicated. We didn't really give you any of that, so if it's bigger than a 2 by 2, I would still go back to finding the inverse. I would still go back to finding that inverse matrix and or using the row echelon that we did today in class. So there's using Cramer's rule. Okay, great with 2 by 2s also. Okay, I think this right here is going to be that expectation is the 2 by 2. Okay, and then what else do we have? Gaussian elimination we talked about. So with row echelon form, so we can do this same sort of thing. but we can set this up as a Gaussian elimination with row echelon form. So I could do this, so another method, right? There's tons of methods for all doing the same thing. So we're still going to solve, this is Gaussian, and I'm going to kind of shortcut that, Gaussian elimination, okay, with, this is row echelon. Right, so with row echelon, so when I do the Gaussian elimination here, so I'm going to set it up, -2, 1, 1, 3, and this time I'm going to put the 5, 7 over here. Okay, so I create an augmented matrix, but instead of putting the identity on the right side, because that's what we use to get an inverse matrix, I'm going to put the what it's equal to over here, and that way we can solve for x and y. So then you go through the whole Gaussian process of trying to get the zeros here. You can go all the way down to the identity on the left-hand side, and it would give you your exact answers, or you can just get the zeros in the bottom left corner. If it's a 3 by 3, then you would get zeros. I think they kind of show it to you here. You would get zeros in these 3 spots, and the rest would be numbers. So let's say I want to do it here. I want to get a 0 right here. So I can do row 2. All right, I'd have to multiply that by 2. And then add to that row 1. And I'm adding because this is already negative. So 2 plus -2 would give me a 0. So I'm going to add those two. So I'm going to do that. So 2 row 2, I'm going to do it off to the side here. So 2, 6, 14, and then -2, 1, 5. And if I add those together, I get 0, 7, 19. Okay, you can kind of already see the numbers that we were looking at before. So then you've got -2, 1, 5, the top one stays the same, and then on the bottom we replace 0, 7, 19. Again, that was the one I wanted to replace, so you decide which one you're trying to change here. I left row 1 the same because I wanted to, but this is my x, this is my y, so I already know that y is going 7y equals 19. Okay, so this is 7y equals 19. Divide that over, y is equal to 19/7. Okay, that's what we got up here, so that's good. And then I can take that and plug it back in, is one option, or I can keep going on this one until I end up with the identity on the left. It's kind of up to you on how you feel. So here, if I want to do this, I'm going to have to plug in a 19/7 and then kind of go from there in order to combine and solve and do all that stuff. So again, that is absolutely 100% up to you on how you want to do this. I feel like this one's going to be a little bit easier to finish it down to the identity, and then I can go from there. So I'm going to do that. I'm going to finish this identity and show you what that looks like. So I can do 1/7 row 2 to get rid of that, make that a 1. So that would give me -2, 1, 5. Okay, 0, 1, 19 over 7. Okay. Either way would work here, because you're going to end up with the exact same answers regardless. Actually, let me do this without, because some of you guys don't like the fraction. So let me do it without doing the fraction so you can kind of see what that would look like. So let me leave this as a 7 and a 19. And then instead, let's change row 1. That sounds fun. Show you what this looks like. So if I wanted to, let's say I wanted to change row 1 and make this a 0 instead without making this a fraction, because otherwise you're going to have to work with fractions either way. I can multiply this by a -7, and that would give me a 0 there. So let's do that. So let's do -7 row 1 and add that to row 2. Okay, so that would give me +14, -7, -35. Okay, that would give me -35 there. And then when I add 0, 7, 19 to that, that would give me 14, that would give me 0, and that would give me, ooh, goodness, 6, -16. Okay, so -16, and then 14 and 0. Okay, so now from here I just need the 1, so now I'll do it, now that I've gotten rid of all of that. So then my very last step is 1/14 of this one up here. Right, so 1/14 of row 1, and then we'll do 1/7 of row 2. Okay, when you do that, you get 1, 0, you get negative 16 over 14, and then 0, 1, and then 19 over 7. So then I didn't really have to do anything with fractions, just my final answer came out to fractions, and my very last step would just be to reduce that. So this is my x, and once you reduce that, because 2 comes out of both of them, you get negative 8/7, which is what we got before, and y is equal to 19/7. Okay, so it's kind of up to you. Again, you could have just taken this and plugged it back in, but then you have to, like negative 2x plus 19/7 equals 5. And you can work that. There's nothing wrong with that. You can take that and solve for x. You can get a common denominator. Right, subtract that over, common denominator, do all of that, divide it by negative 2, and that's perfectly fine. A lot of you guys are perfectly comfortable with fractions, and so you might find that quicker. It's up to you. I was trying to do it with avoiding fractions as long as possible, and this would be the way to do that, is get everything down to zeros, and then that very last step, then go ahead and do the division so that the only time you end up with the fractions is at the very, very end. Okay, so that's what row echelon looks like. That's as far as we have made it so far in class, so I'm going to stop this video there. It is plenty long enough, and then I will pick up with the last 2 sections after we teach them tomorrow and Monday. Okay, so start studying now.